My dear students, it's the latest previous year question asked in 24. It's a work or energy question. He's asking us to find out what is the loss in energy when a ball falls from a height h and rebounds to a height of h by 2. That means 50% of the height only it is able to reach. And you know, energy is nothing but mgh. Potential energy is directly proportional to height. If it is raising to only 50% of the previous height, that means how much energy is lost? 50% of the energy is lost. And before striking the ground, when a ball falls and touches the ground, before striking the ground, you all know the formula is 2gh, root of 2gh according to equations of motion in kinematics. So this is B option, correct answer. That's it. My dear student, this is the latest previous year question asking. You know, gravitational force is a conservative force. In whatever the direction you go, it is same work will be done. How? I am going to show you. Let us see here now. So first thing is, if you take directly upwards, you write work done is nothing but potential energy, which is mgh. But when you go along the inclined plane, you should know that the force acting along the inclined plane is mg sine theta, and the displacement acting is L here. Therefore, work done in the second case here, that is, we can take, this is case 2. In the second case, work done is taken as force which is taken as mg sine theta, and displacement is nothing but L here. But you should know one thing here. Sine theta is nothing but opposite side h and hypotenuse is L. That means L is equal to L sine theta. That means instead of this L sine theta, directly I can write mgh, because L sine theta is h. So in both the cases it is mgh. No need to solve, directly you can tell this one. My dear students, a bullet enters into a wooden plywood and it loses its kinetic energy because its velocity previously it was 100 and now it has become 40 meters per second. Then what is the loss in kinetic energy? For that, loss divided by original into 100. So what is the loss? Loss means initial minus final kinetic energy divided by initial kinetic energy, which is going to be like this. Now, from this, you can cancel out half m in the numerator and denominator. Finally, what is going to be the formula here? Into 100. So if you cancel out half m in all the directions, all the types of, we'll be getting u square minus v square by u square into 100. This is going to be your shortcut formula. This is going to be your shortcut formula. That's it. If you substitute, you'll be getting how much? Nearly 84% you'll be getting now. Can you check it out here? So which is 100 square minus 40 square divided by 100 square into 100. That's it. My dear students, this is the latest previous year question asked in 2024. Here, when a block is moved towards right a distance of 10 meters, when it's moved to a distance of 10 meters towards right here, then what is the work done by an applied force to move a body? You should remember one thing, that in such cases, applied force and friction force are going to be same. And the formula is mu mg. You all know about that. And he is asking us to find out the work done is nothing but applied force into displacement. And you all know applied force is nothing but mu mgs. This is a shortcut formula. You can just apply and get the answer in a super simple way. That's it. Here 0.4, and your answer is going to be 4000 joules. That's it. Thank you. My dear students, how can you solve this problem asking 2024 latest JEE Mains question? So here a force is given and is asking us to find out the work done. You all know work done is nothing but F into dx. That's it. You have to substitute the values here. F is nothing but 3x square into this dx, okay, and plus again integration of 2x into dx, again minus 5 integration of 5x 5 into dx here, and limits are given from 2 to 4 here. So 2 to 4 and 2 to 4. Here you can write now 3. After integration you will get x power n plus 1 by n plus 1 means x power 3 by 3 plus, and limits are from 2 to 4, and this is going to be 2 into x square by 2, and limits are from 2 to, and this is minus 5x, x limits are from 2 to 4. Okay, so here 3 gets cancelled, 2 gets cancelled, and what we're going to get, let us see here. Now work done is nothing but 4 cube minus 2 cube, this is minus 5 into 4 minus 2, 4 and minus 2. So if you solve this one, I think work done, you're getting 58 joules. That's it. My dear students, this is an inclined plane. A block is moved upwards. When a block is moved upwards, friction acts downwards. Then what is the work done by the friction? You all know work done is nothing but force into displacement. Here, what is the friction force? You all know friction is nothing but mu into n, and n is nothing but opposite direction, there is mg cos theta. So mu mg cos theta. Therefore, your formula is going to be mu mg cos theta into s. This is going to be your shortcut formula. If you substitute, you'll get the answer directly. Let us see here. And your final answer is going to be 5 joules when you calculate and substitute here. Therefore, 5 joules is your answer. Thank you very much. My dear students, what happens to momentum when kinetic energy becomes 36 times? First of all, what is the relation between kinetic energy and momentum? Kinetic energy, you know, is p square by 2m. That means p is directly proportional to root k. So p2 by p1 is nothing but root of k2 by k1. So therefore, p2 by p1 is nothing but, it becomes 36 times, means 36 times of the previous kinetic energy, that is k1. How much? P2 is nothing but, this is root 36 is nothing but 6 times of P1. Okay. So P2 becomes 6 times of the previous momentum. What does it mean actually? Here 6 times means P2 is equal to P1 plus 5 times of P1. Okay. Previously it was P1. Now it is becoming 5 times extra is nothing but 500% is going to be your answer. That's it. My dear students, this is a previous year question asked in JEE Mains 2024. A particle blast breaks into 2 pieces. These 2 pieces moves in the opposite direction with velocities Vb and Va, having masses Ma and Mb. Then in such cases, conservation of momentum takes place. That means Ma Va is equal to Mb Vb. Or what I am going to do here, I can write now Mb by Ma is equal to Va by Vb. This is the concept which we get from conservation of momentum. But he's asking us to find out the ratio of their kinetic energies Kb by Ka. And kinetic energy formula, you know, it's a general formula. Half of gets cancels. Mb by Ma as Va by Vb. I'll substitute these values here now. Therefore, Kb by Ka is equal to Mb means I'll take Va by V. Already here, Vb square by Va square is left here. So Vb gets cancelled, Va gets cancelled. What is left finally? So Vb by Va is left. So your answer is going to be B option. So simple it is. My dear students, we can solve this problem by using work energy theorem. You can just see what is the value of velocity here. You all know that velocity is nothing but alpha root x given in the problem. And it said that x is 0 and x is d here. That means initially it is at 0, next it goes to d here. Then what happens to initial velocity? That means v1 is going to be alpha root 0, which is equal to 0. Final velocity is alpha root d. That's it. So as initial velocity is 0, this part is getting cancelled here. Now the next part is going to be work done is equal to half m v square. It is alpha root d, alpha root d whole square. That's it. So w is equal to m alpha square d divided by 2. So therefore D option is going to be your answer. That's it. My dear students, this is a previous year question in JEE Mains. Now let us see here what is going to happen. He is telling that there are 3 masses having equal kinetic energies. Then find the ratio of their linear momentum. You all know the relation here. Kinetic energy is nothing but P square by 2m. Equal kinetic energy means this is going to cancel here. That means here momentum is directly proportional to root m, because P square is directly proportional to m means P is directly proportional to root m. Therefore, for the 3 bodies, P1 is to P2 is to P3 is equal to root of K1 is to root of K2 is to root of K3. Okay. So what is root of K1? Root of 400 is to, this is 1.2 kg means root of 1200 is to root of, this is 1.6 kg means 1600. Okay. So if you solve, your first option as the answer getting. So it is going to be 1 is to root 3 is to 2. Dear students, this is the latest question of JEE Mains 2024. A very simple and silly question. Here, he is asking us to find out the ratio of magnitude of linear momentum when their kinetic energies are same. Equal kinetic energies is telling. So equal kinetic energy means this is going to be constant. Then what is left here? The relation is P is directly proportional to root m, because P square is directly proportional to m here from this relation. Therefore, we can write the ratio of their linear momentum is P1 by P2 is nothing but root of m1 by m2. And you know the masses are given here 4 grams and 25 grams. So 4 by 25, which is P1 is to P2, which is nothing but 2 is to 5, because this is under root. So 2 is to 5 is going to be your answer. That's it. My dear friends, this is the latest previous year question of 2024. In this question, a ball has been dropped from here, and when it reaches here, what is the velocity at this place is asking. You know, when it is dropped, initial velocity is going to be 0. And we use the formula v square minus u square is equal to 2gh. If u is 0, v is nothing but root of 2gh here. So 2, g is 10. So here this is 1 meter, this is 0.5 meters. So what does it mean? So difference you have to take. Only this much height you have to consider. That height is nothing but the difference. 1 minus 0.5 is equal to 0.5, which is equal to again 1 by 2. So into 1 by 2. That's it. 2 gets cancelled. Your answer is going to be root 10. So root 10 is... Dear students, this is the latest question asked in JEE Mains 2024. He is asking us to find out what is the kinetic energy at the lowest point and the highest point. First of all, you all know the velocity at the lowest point is going to be root 5 gr, and at highest point it is going to be root gr. Okay, so you all know kinetic energy is directly proportional to velocity whole square, because kinetic energy is half mv square, mass is constant, only velocity whole square. Therefore kinetic energy at A and kinetic energy at B, v whole square means square root will go. So what is left now? 5 gr by gr is left. That's it. Because whole square and root gets cancelled. Gr, if you remove 5 by 1, so your answer is going to be 5:1. So simple answer it is. In a vehicle there is an electric motor, a constant power source, which is making a body to move. Then what is the relation between displacement and time period? Okay, displacement and time you can say. So how are you going to solve? You all know power is nothing but energy by time. Okay, and you know energy is nothing but power into time. Energy means we can take kinetic energy. That means half mv square is equal to power into time. Yes, power into time. With this it is understood that v is directly proportional to t power 1 by 2. V is directly proportional to t power 1 by 2, because v square is directly proportional to t, and is asking us to find out the relation between displacement and time. And you know displacement is nothing but velocity into time. So here velocity means t power 1 by 2 into t. Okay, t power 1 by 2 into t. So this is a direct relation here, direct relation. So therefore s is directly proportional to t power 1 by 2 plus 1, which is nothing but s is directly proportional to 3 by 2. S is directly proportional to t power 3 by 2. That is the answer. That's it. My dear students, this is the previous year question. Here, a ball starts with a initial velocity 4 meter per second and slowly its velocity decreases. He's asking us to find out what is the final velocity when there is a retarding force acting in the opposite direction, and the limits are the ball starts from 0.5 meters to 1.5 meters, from here to here, and there is a retarding force acting which is equal to minus kx. This problem can be done by using work energy theorem. You know work done is nothing but change in kinetic energy. You all know that the initial velocity is 4 meters, means what is the initial kinetic energy here, which is nothing but half into m into v square is nothing but 4 into 4. So here 16 joules is going to be the initial kinetic energy. So let us find out final velocity here very easily. First of all, work also you have to find out. Work, if you find out, it's very easy to find out now. So how are you going to find out the work here? Work done is nothing but integration of f into dx. So w is equal to f means minus kx dx, limits are from 0.5 to 1.5. So therefore w is equal to x square by 2. So 2 I am writing here. Limits are from 0.5 to 1.5 here. So what is the value of k here? K is nothing but 12. So therefore work done is equal to minus 12 by 2. Here you have to substitute 1.5 whole square minus 0.5 whole square. So finally we are getting how much? Minus 12 as the answer. Because this is going to be 2. So 2 gets cancelled. You are getting minus 12 joules as an answer. So here, you know initial velocity, you know the final velocity. You know the work done here. Work done is how much? Minus 12. Okay, so half mv square you have to find out. Initial velocity already you got. So what is the value of initial kinetic energy? We got it as 16 joules here. Okay, so this is initial kinetic energy which is 16 joules. So now here, if you substitute here 16 joules, so what are we going to get now? Final kinetic energy from this is nothing but half mv square is equal to here 16 minus 12, which is nothing but 4. So from this you have to find out the final velocity. How can you find out the final velocity here? So therefore, final velocity is nothing but 4 into 2 by m here. M. What is m here? You know 2. So therefore, final velocity is nothing. So 4 into 2 divided by mass is again 2 here. So 2. So V square is equal to 4 means V is equal to 2. So 2 is going to be our answer, that's it. Okay. Dear students, this is a previous year JEE Mains question here. Try to understand this question here. It's a very simple and easy question. We can convert this question into a graph and solve it in a super simple way instead of going to integration, differentiation, especially for NEET students. Let me see here. So this is a question actually. Let me explain the question instead of reading the question. There is a box. A man applies a 200 newtons of force up to 15 newton, up to 15 meters. After that, because he reduced his energy, the force has been reduced to 100 newtons now. With these 100 newtons, further 15 meters, he will move the box here. That's it. It's a simple question actually. So how can you convert this into a graph here? See here, this is x-axis in which distance is there, y-axis there is a force here. So 200 to 100 force has been reduced, 200 newtons to 100 newtons. And displacement from here to here 15 and again 15. Okay. So this is actually graph here. So if you draw the lines and cover the graph, now this is to be worked on. If you want to find out, you have to find out the force into displacement. Okay, that means you have to find out the area of this graph to get the work done. So how can you find out the area of this graph? First thing is W is equal to, this is a rectangle is nothing but 200 into 15. So the first part. What second part is going to be a trapezium is nothing but half into sum of the parallel sides. It's nothing but 100 plus 200, sum of the parallel sides, and the distance between the two sides is nothing but 15 here. Okay, so 15. So if you solve this one, it's going to be how much? 3000 plus is going to be 2250. So nearly it is going to be 5250 joules. So your answer is going to be the first option. Such a simple question here it is. There's nothing there to be worrying about this. Thank you. My dear students, on a platform there is a block and the block is moving upward with an acceleration of g by 2. Then what is the work done here by the normal reaction to move it upwards? What is the formula for that? What is the basic concept behind that? See, whenever a block is moving upward, there is a normal reaction acting on the block because of this platform. What is going to be that normal reaction? Whenever a body moves upward, m up is nothing but m into g plus a. This is a common formula. Everyone knows about that. Then what is going to be the normal reaction upwards? This normal reaction is acting like a force of block on the floor here. So it's going to be how much? M into G. It is moving with an acceleration of G by 2, so we can write it as G by 2 instead of acceleration. Therefore, force we got it as 3mg by 2. It's ready now. Okay, so force is ready with you. Then what is the displacement traveled by a block? Upwards. So this is in this certain time here. So S is nothing but half AT square. Because UT plus half AT square, where initial velocity of the block is going to be 0, just half AT square we take. That is half A. A is nothing but G by 2 into T square. Therefore S is nothing but G by 4 into T square. That's it. So you all know work done is nothing but force into displacement. So what is going to be that force into displacement? So force is nothing but 3mg by 2 into displacement is nothing but gt square by 4. Therefore, it is going to be 3mg square t square by 8. So C option is going to be your correct answer. Hope you have enjoyed this problem. Thank you. My dear students, here a rubber band is stretched with certain force and the force is given with a magnitude ax and bx square where a and b are going to be constants. It has been stretched to a length L. Then what is the work done to stretch this rubber band? For that, you know, work done is nothing but f into dx. Limits are from 0 to L. That's it. You can just do the problem here. W is equal to integration of 0 to L. F means we can take ax plus bx square. So ax dx plus integration of bx square dx. And limits are from 0 to L. So here the work done can be written like this: a into x square by 2. In the place of x you have to write L. That's it. X square by 2 means L square by 2. That's it. Now plus b x cube by 3. X cube means x place low. We have to keep L here. So x cube by 3 is nothing but L cube by 3. That's it. Such a simple and two-step solution I have given you. That's the answer is going to be how much? It is going to be D option. My dear students, let me discuss the concept of ballistic pendulum. What is the meaning of ballistic pendulum? A wooden block is hanging. A bullet enters into the wooden block and both combined together move with a common velocity raised to a certain height h here. And he's asking us to find out what is that height h. What is the concept behind this? Let me discuss one by one. So this is a bullet which is entered into the block and making the block to rise to certain height h here. So we need to find out this height h here. How are you going to find out the height h? The first thing is conservation of momentum before collision is equal to momentum after collision. So here, before collision, what is going to happen? See, bullet is moving, having a certain mass, small m, and block is having a mass cap. Bullet is moving, before collision, bullet is moving with velocity v0. Okay, whereas the block is at rest, so we can take it as 0 here. And after collision, bullet and block moves with a common velocity. That means small m plus capital M. The bullet embedded in a block, both move with a common velocity, we see here. And that what is the common velocity? Let us discuss here. The common velocity is m into v0 by small m plus capital M. Okay, so this is said to be the common velocity of both. Now, the second part of this concept is conservation of energy. What is the meaning of conservation of energy? Let us take this is position 1, this is position 2. Total energy at 1 is going to be equal to total energy at 2. So here total energy at this place, here there is no potential energy because it's the bottommost point here. It is 0. And what is the kinetic energy? Half into small m plus capital M into Vc whole square is equal to what is the total energy at this place. Here the block and the bullet is going to stop, so there is no kinetic energy, only potential energy is there. And the bullet plus block is small m plus capital M into G into H, that's it. And where the kinetic energy is going to be 0. Therefore, this is the concept here. So this is going to be cancelled. Then what is going to happen here? So therefore, Vc square is equal to Gh. And this 2 goes to that side, becomes 2Gh. Okay, so what are we going to do here? He is asking us to find out the height h. So h is nothing but Vc square by 2g, which is nothing but Vc square is total the value of this one. So therefore, m square v0 square by small plus capital M whole square into 2g. Okay, this is going to be the formula 2g. That's it. So here Vc square means total value whole square divided by 2g. So this is your formula now to find out. So we can just simplify this formula and keep like this. This implies that height h is nothing but m by small m plus capital M whole square into v0 square by 2g. That's it. Okay. So we need to substitute the value of small m, mass of a bullet, capital M, mass of blast, v0 square. What is given in the problem? You can just see one by one. Velocity of the bullet is given. Mass of the block is 1 kg and mass of the bullet is 10 power minus 2 kg. And it's nothing but g value, you can take it as 10 here. So everything is present. So directly if you can substitute in this formula and get the answer, okay, so your answer is going to be 0.2 meters. You have to get that answer when you substitute in these values, what are the values given in this problem here. My dear students, one of my students asked this doubt. It appears to be a very complex question. It is a question of work here. He has given the mass of a body as 500 grams, which is nothing but half kg. And he has given the value of V, a typical value he has given, but nothing is there to worry. So he is asking us to find out the work done, isn't it? Work done is asking, and the limits are from x is equal to 0 to 4. As 0 is considered, there is no chance of taking 0 because there is no displacement, and you have to take it as 4 here. X is 4 here. Now, here I have taken a value of V first of all. I have found the V here. Bx power of 5 by 2. X is equal to, he has given it is as 4 here now. So I have taken 4 power of 5 by 2. 4 is nothing but 2 square and B value is 0.25. I have taken as 1 by 4 so that calculation gets easier. So this is 1 by 2 square, then 4 means 2 square, 2 gets cancelled, 2 power 5. So 2 square, 2 power 5 gets simplified being 2 cube here. That's it. So W is equal to half. Mass is how much here? 500 grams means half kg. Into V square is nothing but 2 cube whole square again. So this is 1 by 2 square into 2 power 6. So this is getting cancelled, it's going 2 power 4. So okay, 16 joules is going to be our answer. That's simple. My dear friends, see the lengthy methods given in the books regarding the question here. So if energy becomes 4 times the initial kinetic energy, then what is going to be the momentum? This is the problem actually. So you know, first of all, what is the relation between kinetic energy and momentum? Kinetic energy is P square by 2m. P is directly proportional to root K. That means P2 by P1 is equal to K2 by K1. Here he says that kinetic energy becomes 4 times. What does it mean? Kinetic energy becomes 4 times means P2 by P1 is nothing but square root of 4 times of the previous kinetic energy. So therefore, P2 is going to become 2 times of P1. Okay, so this is 2, so 2 times of P1. That's it. So what is the meaning of this? Here, momentum becomes double. What is the meaning of momentum becomes double? See, already this much momentum was there. Now momentum has become extra, double. That means this is already 100%. How much extra? 100% extra. That is, answer is 100% extra. So that's going to be a simple solution instead of following this lengthy method. Thank you. Good news for NEET aspirants. How can we bypass the integration and differentiation methods used in the books to solve especially this type of problems, where a body having a constant power source is moving forward? Then what is the relation between displacement of a body and time here? That is asked here now. So you can just see the lengthy methods given. Finally, he is telling that S is directly proportional to T power 3 by 2. But we have got a simple shortcut method. You know, constant power is there. Power is constant. Power is nothing but energy by time. Energy can be considered as kinetic energy, half mv square by T, which is equal to K. You all know velocity is nothing but displacement by time. So we can write like this. So instead of V, we can write half m. V means displacement by B square means S square by T square. Already T is there, means here T cube it will become, which is equal to K. From this it is understood that mass is constant, this is also constant. S square is directly proportional to T cube. That means S is directly proportional to T power of 3 by 2. This 2 goes to that side, become 3 power 3 by 2. So as for S is directly proportional to T power 3 by 2 is your answer. Thank you very much. Have a nice day. My dear students, what is the work done by a man to lift a bucket from the well with full of water? So here, work done, if you consider, is nothing but mass of a bucket with water is mg and length of the rope is considered as L. So instead of mgh, we have to consider mgl here. But after that, as the rope is also having certain mass and this is the length of the rope, but you have to consider as it is a uniformly distributed body, rope is having uniformly distributed mass here, we have to consider only center of mass of the rope. That means you have to consider only half of the length of the rope, not the complete rope. That's why we write this as mg into L by 2. That's it. So combined together, if you take, that is going to be work done by a man to lift a bucket along with a rope with mass. If you consider the rope without mass, there is no mass in the rope. That means massless rope if you consider, then the formula is going to be just mgl, where L is said to be the length of the rope here. If you consider the mass rope having certain mass, then it should be again as mgl by 2. That's it. This is an extra part to be added to this concept. Thank you. My dear students, what is the work done in lifting a pendulum to a certain height h? So this is an height h. What is the work done in that case? So you all know this is length L. If this is length L, this is making angle theta. That means this part is going to be L cos theta. That's it. So this is going to be L cos theta, the component of the length here. You have to find out h here. What is going to be this h? H is nothing but, this height is nothing but, the total length is going to be L here. So this is going to be L minus L cos theta gives you height h. So L minus L cos theta. So h is equal to L into 1 minus cos theta. That's it. You need to find out what is the work done. As the pendulum is going against the gravitational force, we need to consider this as minus mgh. That's it. Minus mgh. So W is going to be minus mg. H is nothing but L into 1 minus cos theta. Okay. So this is going to be our final equation. Find out the work done in lifting a pendulum to a certain height. That's it. My dear friends, what is the work done in lifting a rod to a certain angle theta here? Let me discuss about that. Let us consider the length of the rod is L. As the rod is a uniformly distributed body, we have to consider just only half of the length of the rod. This much rod you will consider. Then what happens? If this is L by 2, then what is this going to be? L by 2 cos theta, which is the component of L by 2. Then what is this? This is nothing but L by 2. The same half of the length of the rod. Okay, then this is going to be the height h. So what is the height h here? Height h is nothing but if you want to find out height h, you have to subtract L by 2 cos theta from L by 2. So L by 2 minus L by 2 cos theta. Therefore, h is equal to L by 2 if you common out 1 minus cos theta. So what is the work done here? Work done is nothing but minus mgh, because you are taking the rod against to the gravity. That's it. So therefore, that can be taken as minus mg L by 2 1 minus cos theta. So this is going to be your final expression for lifting a rod against the gravitational force. Thank you. My dear students, what is the work done in lifting a ladder which is resting on the ground horizontally to the wall? And then what is the work done in lifting a ladder here? That's the question actually. You should know that the length of the ladder is L, and as it is a uniformly distributed body, we have to consider the center of mass of the ladder at this place. And now this is going to be the half of the length of the ladder, and the angle made by the ladder with the ground is taken as theta here, and this is going to be the height of center of mass of a ladder. Then what is the work done in lifting a ladder? You should first of all find out what is this h. You should know that sin theta is nothing but opposite side by hypotenuse L by 2 here. That means h is equal to L by 2 sin theta. H is equal to L by 2 sin theta. And you should know that work done is nothing but minus mgh when you are lifting a ladder against the gravity in the upward direction. Therefore, that's why we take minus g, because it is moving opposite to the direction of gravitational force. So therefore, this can be taken as minus mg L by 2 sin theta is going to be your final step here. That's it. Thank you very much. Dear students, what is the work done in pulling the chain completely on the table when L by nth part of a chain is hanging? How much part of a chain is hanging? L by nth part of a chain is hanging, but you have to consider the center of mass of that hanging part. So center of mass of this hanging part is in the middle, so you have to divide with 2, then it is going to become L by 2n, and this is going to become h here now. So okay, h. Therefore, work done in pulling the chain upwards against to the gravitational force is considered to be minus mgh, because it's going opposite to the gravity, so minus sign will come. Therefore, here instead of m, total mass of the chain is m, but the hanging part is having the mass only m by n. Therefore, mass of the hanging part g into height of the hanging part, you should consider as nothing but minus m by n g into h. H means it is going to be L by 2n. So your total concept is mgl by 2n square. That's it. Now let us go for the next topic regarding chain here. So when half of the chain, if you lift it and make it to hold at the same place where the total chain is hanging, then what is the work done? So how much part of the chain we are going to lift? Only this much part of the chain you are going to lift here and make it to hold at the top point of the ceiling here. Then what are you going to do? So among this half part, how much part of the chain is considered to be from the center of mass? So the center of mass part of the half of the chain is this much. That means the remaining part is going to be L by 4. So here height of the chain which has been lifted is taken as L by 4 here, isn't it? Then this is said to be the height which is lifted, hanging. Then what is the mass? What is the work done here? Here the work done is nothing but mgh minus. So it's minus sign, minus mgl by 4 is going to be your answer, because this is the concept here. L by 4th part, as it said here. My dear students, what is the work done on the chain which is resting on the table and some part of the chain is hanging? How much part of the chain is hanging? If the total mass of the chain is m, here only m by nth part of the chain is hanging, and here the total length is taken as L by n, and here is a uniformly distributed body. That's why we have to consider a center of mass of this body. Therefore, the hanging chain should be divided by 2, because you have to take only 50% of the uniformly distributed body. Therefore, you will be getting L by 2n. So therefore, mass of the hanging chain is m by n, and length of the hanging chain is L by 2n. So work done in pulling the chain totally on the table is work done on the hanging chain to pull it completely on the table is mass of the hanging chain G and height of the hanging chain. So this is going to be the height of the hanging chain here. Okay, so you can consider this as height of the hanging chain G, and height of the hanging chain is considered as L by 2n. Therefore this can be taken as mgl by 2n square. This is said to be work done in pulling the total chain on the surface of the body. Let us solve the problems related to the chain hanging. Now you all know that the formula for pulling the chain, the work done to pulling the chain on the table is taken as here mgl by 2n square. Here n means 1/6. Here 1 by 6 is nothing but 1 by n. In the place of n you will be getting 6 here. So work done can be taken as mgl by 2 into 6 square. 36 into 2, that is mgl by 72 is going to be your answer. Okay, so this is the first option. Dear students, what is the work done in pulling the chain completely on the table when L by mth part of a chain is hanging? How much part of a chain is hanging? L by mth part of a chain is hanging, but you have to consider the center of mass of that hanging part. So center of mass of this hanging part is in the middle, so you have to divide with 2, then it is going to become L by 2n, and this is going to become H here now. So okay, H. Therefore, work done in pulling the chain upwards against the gravitational force is considered to be minus mgh, because it's going opposite to the gravity, so minus sign will come. Therefore, here instead of m, total mass of the chain is m, but the hanging part is having the mass only m by n. Therefore, mass of the hanging part g into height of the hanging part, you should consider as nothing but minus m by n g into h. H means it is going to be L by 2n. So your total concept is mgl by 2n square. That's it. Now let us go for the next topic regarding chain here. So when half of the chain, if you lift it and make it to hold at the same place where the total chain is hanging, then what is the work done? So how much part of the chain we are going to lift? Only this much part of the chain you are going to lift here and make it to hold at the top point of the ceiling here. Then what are you going to do? So among this half part, how much part of the chain is considered to be from the center of mass? So the center of mass part of the half of the chain is this much. That means the remaining part is going to be L by 4. So here height of the chain which has been lifted is taken as L by 4 here, isn't it? Then this is said to be the height which is lifted, hanging. Then what is the mass? What is the work done here? Here the work done is nothing but mgh minus. So it's minus sign, minus mg L by 4 is going to be your answer, because this is the concept here, L by 4th part, as it said here. Let us solve the problems related to the chain hanging. Now, you all know that the formula for pulling the chain, the work done to pulling the chain on the table is taken as here mgl by 2n square. Here n means 1/6. Here 1 by 6 is nothing but 1 by n. In the place of n you will be getting 6 here. So work done can be taken as mgl by 2 into 6 square. 36 into 2, that is mgl by 72 is going to be your answer. Okay, so this is the first option. My dear students, this is a question of conservation of momentum. Let us see here. A man is standing on a trolley and he is running on that trolley with a speed of 1 meter per second. His weight is 80 kg. As he is running forward on the trolley, the man and the trolley combined together, it is moving backwards with a speed, sudden speed. We don't know what is that speed. We have to find out that speed here now. What is the weight of that trolley? It is 320 kg. Conservation of momentum. That's it. See here, momentum of a man is equal to momentum of a man plus trolley, because both combined together they are moving. Okay, so momentum of a man is 80 into 1, which is equal to mass of the man and the trolley is going to be combined together is 400 into velocity of the trolley in the backward direction. So velocity of the trolley is going to be 8 by 40, that's it, because 0 gets cancelled here. It is going to be 1 by 5, which is 0.2 meter per second. It is going to be the velocity of a trolley in the backward direction. You have to find out what is the pure velocity of a man. Because when man is moving forward, trolley is moving backward. But what is the pure velocity of a man? Pure velocity of a man is going to be how much? It is going to be 1 minus 0.2. He is moving forward, trolley is moving backward. So difference will give the pure velocity of a man, which is nothing but 0.8 meters per second. He is asking us to find out how much distance the trolley has traveled from here to here, how much distance backward it has been traveled. So displacement is equal to pure velocity of a man into time here. Okay, so what is the pure velocity of a man? He is going to be 0.8, and in the time of 4 seconds, that is 4. So this is going to be 3.2 meters. That's it. This is going to be our solution. Hope you have enjoyed the solution. Thank you. My dear students, welcome to shortcut concept explanation. Any concept in a shortcut method, let me explain here. When a block has been dropped here, it slides down and reaches this point here. Whenever it is dropped from here, its initial velocity is going to be 0. It comes down. What is the work done by gravitational force to pull the body from the topmost point to the bottom point here? Let us see the work done by the gravitational force. You all know this is going to be angle theta. So here it is going to be mg. In this direction it is going to be normal reaction. In this direction it is going to be theta. This is going to be mg cos theta. In this direction it is going to be mg sin theta. As there is no friction in this direction, there is no friction force here. Only it's a smooth inclined plane. Then what is the work done by the gravitational force? The resultant force acting on the block to slide down is mg sin theta. And work done by gravity to pull the body from topmost point to bottom point is nothing but force into displacement. And let us take the length of the slope is taken as L here. That means displacement is taken as L here. Therefore, work done by gravitational force is nothing but mg sin theta into L, which can be taken as Wg is equal to mgl sin theta here. That's it. For example, this is going to be the height h. You all know sin theta is equal to opposite side h by length of the slope, hypotenuse taken as L here. That means h can be taken as L sin theta. Therefore, we can also write Wg is taken as mgh here. Okay. So as the block is coming downwards, g is considered to be positive. This is said to be positive work done on the block. Thank you very much. My dear students, what is the work done in making the block and taking the block to the topmost point of an inclined plane, which is said to be the smooth inclined plane? Let us take an angle theta of an inclined plane. This is going to be angle theta here. When you push it upwards, what are the forces acting on the block? One thing is mg is always acting downwards. Normal reaction acts in this direction, opposite to the normal reaction, making certain angle theta here. These two angles are going to be same. This is going to be mg cos theta, and this is going to be mg sin theta. That's it. Okay. So you are taking an incline upwards. Then what is the length of an inclined plane L here? Let us see what's going to happen now. So work done is nothing but F into S, F dot S. Okay. Here displacement is taken as the length of the slope. And as you are going opposite to the direction of gravitational force to the upward direction, then this is taken as minus here. Okay, so which is nothing but mg sin theta minus mg sin theta into S, displacement is taken as length L. Therefore, W is equal to minus mgl sin theta. That's it. Okay. You know that this is going to be the height of an inclined plane. You can write sin theta is going to be opposite side by hypotenuse. That is nothing but h by L. H is nothing but L sin theta. That means you can replace L sin theta with h. Okay. So work done against the gravitational force to push a body upwards is considered to be mgh also, if you know height h here. That's it.